This is the life cycle of a standalone AI worker. It processes a heavy load, hits its limit, and resets to 0. A standard chat session is restricted by its context window. As you feed it a code base, the token count climbs until the earlier parts of the conversation are discarded. Every new session effectively starts with amnesia. Attempting to scale this by running multiple chat tabs in parallel creates 5 isolated workers. They cannot see each other's work, share project context, or coordinate across different repositories. Complex engineering demands persistent state. To solve a multi-day refactor, you need a system that maintains a continuous thread of knowledge across every simultaneous process. Without shared memory or parallel coordination, the solo agent remains a localized tool. It cannot bridge the gap to a production-ready workforce. The solution is to transition to a factory floor. The Agenti ecosystem is a self-hosted 4-pillar architecture engineered to run Claude Code agents as a synchronized fleet. A managed workforce requires 4 structural components: a floor for execution, a harness for safety, a front door for network access, and a shared mind for state. These map to 4 open-source pillars: AgentiCore for the engine room, AgentiHooks for the harness, AgentiBridge for the network, and AgentiBrain for the vault. Strictly decoupling these components is the key to stability. By separating the execution layer from the network fabric, you remove the centralized bottlenecks and enable genuine parallel scaling. AgentiCore is the foundation of the execution architecture, a single binary deploying in 2 distinct modes. On the left, fleet mode, a work-stealing queue scaling from 1 to 1,000 containers via KEDA. Each fleet mode pod clones a repository, ships a pull request, and recycles the container. On the right, agent mode. This is your persistent specialist consultant. It presents as an OpenAI-compatible streaming endpoint, plugged directly into LibreChat, used natively in OpenWebUI or through a standard curl command. Agent mode retrieves its instructions, tools, and identity from a separate package registry known as AgentiHub. AgentiCore provides pure compute power, but running LLM workloads at this volume without embedded safety mechanisms quickly leads to cascade failures and high operational costs. Raw execution requires local control over guardrails, identity, and token consumption to remain viable. This is AgentiHooks. This Python dependency loads natively inside the session. It is not an external proxy. It enforces strict guardrails. A retry breaker stops the session after 5 failures, preventing the agent from spiraling into an expensive hallucination loop. Hooks also manages context intelligence. By actively compressing tokens by 30 to 50%, it reduces context bloat and lowers operational costs by 1/3. It handles this without adding latency by intercepting specific lifecycle events, like pre-tool use and post-tool use, and cleaning the transcript before it is sent back to the model. Nesting these guardrails directly in process ensures the workforce stays safe at the source. You no longer need a centralized proxy to inspect every token of network traffic. Most AI frameworks rely on a master dispatcher topology. When running multiple agents in parallel, funneling all execution, tool calls, and memory through a single monolithic proxy creates a permanent choke point. We solve this with AgentiBridge. This is the Model Context Protocol front door and the agent-to-agent registry. Bridge registers agent capabilities and indexes memory. It never dispatches jobs directly to AgentiCore. Parallel transports allow heavy workloads to bypass the bridge layer. The operator connects directly to the core instances through REST pipelines, using post jobs for the fleet and a completions path for specialized agents. This allows high-speed execution to flow unhindered. The network fabric handles identity and memory, while the actual work happens through direct, unblocked channels. Institutional memory must outlast any single session, ensuring that every hard-won lesson is permanently retained by the active workforce. This is AgentiBrain, a 5-service kernel over a Markdown vault. Work is grouped into arcs, multi-day focus blocks. A 2-hour tick engine synthesizes these arcs, keeping new lessons and decaying old data. A broadcast protocol then pushes this knowledge back to the fleet. This updated context is injected directly into the next prompt of every active worker. A lesson learned by one pod in the afternoon is available to the entire fleet by the next session. This closed asynchronous loop enables stateless containers to operate as a single cohesive entity with a shared mind. This is the finished architectural topology. By decoupling the network, runtime, guardrails, and memory, The system eliminates the proxy bottleneck. This synchronized workforce replaces the volatility of the isolated AI session with a stable factory floor. This environment is currently operational. It is capable of running 8 parallel, context-aware agents simultaneously on your own machine. Scale is achieved through the engineering of the distributed environment. The control plane provides the structure that the individual model cannot. Orchestrating up this level requires total authority over your infrastructure. The Agenti ecosystem is defined by its engineering constraints. It is self-hosted, MIT licensed, and operates with zero SaaS vendor telemetry. It is built for a single purpose: one operator, one factory floor, one identity. The era of the isolated solo worker is over. Production pipelines demand a synchronized workforce. Take the wheel.